And then our main event, Don, he's the chief enterprise architect, and he and I had a great conversation on the phone, and he's like, well, what do you want to talk about? And I just kept on listing things, and he's like, okay. So he can talk about anything. And so I'm really excited to hear about big data and machine learning, and he may even talk about R tonight. So we'll see what's on his deck, but I'm really happy to have you here, and thank you for making the trip and bringing your goodness to our group.
Good evening, Charlotte, and thank you. Thanks, Dan. It's great to be here, and I'm also appreciative of all the great beards in the crowd, because I think you're going to push Seattle and Portland out, so that's always good to see too. So tonight we're here to talk about a sort of a potpourri, if you will, of stuff, and I hope that you can see the linearity that I hope to tell here. So it's a long story that I don't often get to hear, so I was pretty excited when Dan sort of gave me the whole list of things that he was interested in hearing about. So we'll see in 60 minutes if I can pull this together. So the idea is to take you from the global events and drivers that define what a business does or wants to do, down through the org chart of capabilities, down through services and applications, down to data, the structures that hold data, and bring relevancy to business strategy, and ultimately to IoT, that's providing the ability to sense business ecosystems in our environments around us. So our title, Delivering Near Real-Time Value to Global Markets with a New IoT Mindset. And when I say the new IoT mindset, that's because we're breaking loose of proprietary standards. Open standards are coming to bear. As I look around the room, there's a lot of millennials in the group, and you folks are the digitalists that didn't have to grow up with the burden of 8-track tapes, CB radios, and shifting gears. And having raised 7 children, they grew up on Linux, and I made them appreciate open source as they grew up. But this notion that we have to stick with sort of the industry proprietary standards is now come to bear, and we'll talk a little bit about that tonight. So my job at Micro Focus, formerly HPE, and within Vertica, is to look at enterprise architecture for our clients. And I'll talk a little bit about what an enterprise architecture is in a moment. So I've never had a creative thought in my life, so let's just get that started. All of us take from everyone else. I like these meetups. I get to go to them around the world. And I got to meet everyone from a young woman who's in 10th grade, 11th grade in high school, who's acoustically modeled the sounds inside of a beehive to understand its health and be able to help beehive farmers throughout the Warsaw and Greater Poland area, to folks like yourselves. This is a global community that's coming together with things like Facebook and Slack and other mechanisms to help share this stuff. So what you're doing is part of a global conference of people, and I'm happy to be part of that. So that said, this is where we are. The industrial age is over, the information age is on, and now we're at the digital age. And look at that, the amplitude of that arc off to the far right, and the rise of data. And now we've got to make sense of all that in a near real-time way, because no one's going to wait and sift down through that. I think that probably a third of you have never had to suffer through the Encyclopedia Britannica or the World Book. We used to have to suffer through large volumes of stuff. Now we can go to a search engine and get value very quickly. So this digital mesh is what we're involved in now, this beginning. And it's about building a cooperative, portable, interoperable ontology of taxonomically organized and reusable, valuable data. We'll cover what ontology and taxonomy is in a second, but taxonomy is the verticals and ontology is the guts are down at the bottom of the vertical, if you will. So there's a lot of data coming, so just to give you an idea, 4,000 gigabytes per day as soon as you get your smart car out there, your autonomous car. So the data is coming from everywhere and all kinds of things, and we have to get it valued. Just in the time that I've been speaking, around 3,500 Instagram photos have been uploaded. Look at the volume that we're going to see. And you've seen this picture before, but to give you an idea, something in the order by 2020, 1.6 zettabytes of data. The number of IoT instances, somewhere between 25 and 75 billion, is just phenomenal, and you're a part of that fabric. And the goal is to figure out how to get value of it fast, now. So to begin with, what's the Internet of Things? So I made this up for a standards board that I work with. I'm one of the people that helps to volunteer at the Open Group. I've been doing that for almost 19 years now. You can find that at opengroup.org. And we're the people that help to do things like Unix and TOGAF and some others that we'll talk about soon. But the Internet of Things is this notion of a network of physical objects that contain embedded technology to communicate and sense or interact with objects' internal state or external environment. And I've added more recently this notion with that capabilities increasingly seen as independent and now autonomous. They're learning from each other. There's more and more peer-to-peer communications. They may not be using the TCP stack. They may not be going to data centers. They may just be working autonomously and working with each other. With an increasing demand for interoperability, these things they need to talk to each other. We're going to do a little game here shortly so that we can see how interoperable this group is. And often these things are heterogeneous. They're proprietary. There's consumer things and there's industrial things. There's things that are like Fitbit and Nest and smart refrigerators and so on that we think of every day that we buy as commodities. And there are things that you saw earlier with Dan's group looking at thread machines. This notion of OT, the operational technology space of factories. So tonight we're going to cover essentially these 6 things, I hope. So this is a quick synopsis. This notion of real-time, near real-time value to global markets getting faster and more reliable than ever. There's 3 concepts of latency, interoperability, and cost. I'm going to say that I think 6 or 7 times. Mostly we're going to talk about latency and interoperability, but cost is one of the things that happens as more stuff gets out there, it becomes commoditized. The more autonomous cars that are out there, the cheaper that gets. The only thing that defies that is my old VW bus, which I bought for $800 39 years ago, and I just sold it for an impressive amount of money. And I can't believe that that old piece of machinery is worth that much money. But generally speaking, what happens is things get older, they get cheaper. The data-driven enterprise requires different kinds of data. So we're all hearing about big data, and we're going to talk a bit about that, but increasingly it's about write data, light data, and now liquid data that's correlated to value. Because if you got big data and you can't get data value out of it very quickly, it loses why it's even existing. So we're going to compare big data with infrastructure costing. And we're going to look at smart cities, a little bit about connected cars, a little bit about factory OT, and they require things like sustainability. They have to last for a long period of time because in smart cities, who pays for smart cities? Raise your hands, because you do. Some corporation is not going to pay for it. We're going to talk about that, a bit of a dialogue as well. Interoperability is the biggest roadblock that you're going to have the next 10 or 15 years. And the idea is that all of us create stacks of IoT that don't talk to one another and they need to. And ultimately, I'm going to conclude with one slide, which is, now I'm getting to the point in my life I can make forecasts for things and you won't make fun of me too much. So I'm going to suggest that there's a future for low latency clouds with blockchain and IoT, and I think those are the big disruptors that we'll see. So let's take off. Stories. So all of you tell stories to get your job done. That's the thing that I've learned with millennials. You like stories better than you like reading books of process. And those stories help to relate to the books of process to help you to remember them. My generation spent time learning slide rules and learning facts and things and algorithms and equations. You resolve them by understanding stories. So one of the ways you can do that is apqc.org, the American Productivity and Quality Center. You can go look at the models they have there, but as you build IoT, the idea is to understand the questions that the data that the IoT is presenting must answer. So go to apqc.org, and the next slide I'm going to show you some of the 509 questions that they say the role called CIO must answer. And so if you're building data sets and you answer those 509 questions, you're likely to answer most anything that a CIO could ask. So there's a process classification framework, a PCF that they have for some 11,000 jobs. So about every job that you can think of has a process with it, has questions with it, and has metrics associated with it. So there's the address for some of the content about millennials and the roles that they take. And I'll mention IT for IT is another framework that I use as an enterprise architect to understand how to tell the story of IoT across the enterprise. So this is hard to read. When you get this deck, you can look at it closer. But essentially, those are some of the questions that a CIO asks with the metrics. It gives you the algebra for it, with what the metric is called. So there's some linear algebra in there. You can actually work that out to find out what, as the data comes in, how to manipulate it in such a way to answer the question that the role has. IT for IT is a standard owned by the Open Group, but essentially it's a model, and I don't understand why that's not showed up. Oh, there it goes. It's a model that essentially shows you the functional architecture of enterprise that's related to products that you buy, that's related to the strategy that the business is trying to achieve. And so that's the model on the right. Those 23 blue boxes actually relate to products that you buy within the enterprise. Underneath those products is data. Underneath that data, you may find a lot of IoT. Above this model is the strategy that business has, and businesses have strategy that goes out to the market and tries to find gaps, and that's how we get revenue. So using enterprise architecture, so that's what I do. Enterprise architects essentially look at the domains of business, data, application, and technology. We're not so much nerds as we used to be. When I first started, it mattered that I had some aerospace background and computer science degrees and so on. Those days are gone. Now we want generalists. So the idea is that given the dynamics of an enterprise, what's necessary to exist in an enterprise to go where the strategy wants to go, and to look at the governance of those domains of BDAT, BDAT, Business Data Application Technology. I use various models, FIA, DODAF, TOGAF, MODAF. Those are architecture frameworks to understand what might be missing from the enterprise and how to get it. And it includes lots of artifacts and deliverables that we can use to make the technology story relevant to the business. In the course of my work experience, 60% of my time is doing family counseling, and 40% is doing technology. In the course of this deck, you'll see that it doesn't look very technical, Don. Well, it's not, because family counseling isn't very technical. It's about telling a story. And ultimately, there's some code that's in there, and I'll keep some nerds awake with the code that we'll show eventually. So that's what EA does. Most EAs don't report to the CIO. So if you're trying to get money for your IT projects, find the EA. Most of the time, they work for the operating officer. Only 15 to 20% of the time, they work for the CIO. We used to all work for the CIO, but now we've moved on because that's where the action is. A few terms. Global events and drivers, I've mentioned it. This list from top to bottom, global events and drivers relates to strategy, to org charts and roles within the organization, to capabilities, to services and process and applications, to data and value. And the goal is, if you're trying to sell your IoT projects within an organization to a market, is understand that traceability. Now, when I grew up to be a nerd, or a geek, or an engineer, we never learned this. But now what's happened is that we have to know it in order to get funding. So if you want to get funding for your IoT project, understand how to fulfill that. So if you're building an IoT instance that does weather, for instance, you need to understand the data that's going to create, the other objects that exist within the stack to build some interoperability, the size of the data that's going to be transited across the enterprise, what the cost of that transit is, what the latency of it is, how to relate that to some service, how to relate that to a role, and ultimately, does it tie to business strategy? Because if it doesn't tie to business strategy, how much money are you going to get? None. So let's look at IoT and the many standards problem, because it is a problem. If you look at that picture, you all can probably agree with it. You've got all these cool devices talking to clouds, and those clouds talk to each other? No. If you have a PED worth of data in Amazon and you want to move it to Google or to Azure, is that an easy thing to do? If it's easy, I'm going to come hang out with you. So it's a bit of a problem. So increasingly, those things need to talk to each other because those black lines represent latency. And the fact that they're separate from those other things represents interoperability. Data is collected in silos, they don't talk to each other, and M2M, machine-to-machine communication is limited to the local area network. We have to use TCP in this model. And that's not a great story. Who thinks TCP is cool but fat? It's cool but fat. And it's worked for a long time, it's great, but we may need to go faster. And increasingly, we have cars that are full of these systems. And people want to buy a car. They don't want to buy the systems and integrate them. And everyone in this room would like to create a different one of those systems, I think, and sell it to some car company. But do you want to talk to each other to integrate those systems? No, because that's a lot of work. So we've got to figure out some way to do that, and that's where standards come in. So a couple of the open group standards, again, opengroup.org. OMI and ODF, that's the Open Message Interface and the Open Data Format. Those are two, and another one that's not up there, I'll show in a minute, is the Open Data Element Format, or Open Data Element Framework. That's three of them. And those three, underneath the Open Platform 3.0, enabled you to build a platform of IoT, of verticals of IoT that talk to one another. It deals with the format of the thing, the message of the thing, and how the things talk to each other. Yes, sir?
We were just talking today about getting away from AWS, going to an architecture that can be moved from whoever will sell us servers.
Yes.
The cheapest. Is this a model that can be applied for things outside of IoT, or is this Is this generic, like, can we talk about moving gigabytes of data and stuff?
Yes, that's a good question. So I'm going to show you in a couple of slides how the United Nations is using one of these models in order to deal with bill of lading for ships. If I'm loading a ship in Peru and I decide that the product on there can't be unloaded in Amsterdam, how to use an interoperability model to do that. So it could be applied to anything. In fact, in explaining it to most people, that's how best to do that. At the end of this deck, which is quite large, and I need to move faster, I've included a little class on ODEF, so you can look at that. And if you have questions about it, just give me a call. But it's got some samples that are in there. So ultimately, what we want to have is just two-way time. What we have is two-way time-limited information between trusted products. And ultimately, we want to trust all that stuff. And the idea today is it's hard to do. There's not interoperability, and the vendors are not incentivized to have that interoperability. So those red lines can be fixed with OMI and ODF. And ultimately, Open Platform, which I will show you shortly, is a standard that I've worked on for the last 5 or 6 years. And that platform enables you to have a service catalog talk to it, and essentially the platform can work within one or many enterprise and can cooperate or interoperate with other enterprises so that as you do M&A, there's a method to go through that. So imagine you can take your IoT that's bought in one business tied to a platform, move it to another, and it stays integrous. Closed loop lifecycle management, often called CL sub 2PM. The idea is that increasingly those things need to talk to one another. So how can we do that? What's the model necessary to do that? So we're working on those standards now. And again, you can log in, and all those products are free, and you can use those. And I'll suggest that those work products that we do at the Open Group are your business requirements and some of your technical requirements for products that you create to align with those standards. So this is typical IoT today, cloud to REST API to MQTT to some machine device. How many folks think that REST is a standard? Anybody? Oh, come on, don't do that to me, Skipper. It's somewhat, because all of us in the group may have agreed on an implementation, but it's not a standard. So this is a standard chart that I started some years ago, and I've given up keeping because there's too many standards in it. And I believe at last count there were some 130 IoT standards that are out there. And the problem is everyone has their own standard. That's not a great story. Someone told me the other day it takes 19 plugs to drive an electric car from Istanbul to Edinburgh. It's about $600 worth of just the plugs to plug your electric car in. And if you've done any travel overseas, and tomorrow I'll be in Oslo, I have to carry 6 to 8 plugs just to deal with the US and Europe. And that seems kind of silly, doesn't it? There should be one standard. We've all agreed on TCP. We've kind of agreed on what webness does, but we need to do that same thing for things. REST isn't a standard. We said that before. The idea is that we need some mechanism for doing that. So what you're seeing today is we're starting to come down the stack. We're building smart gateways to try to deal with some of the named ontologies that exist within an infrastructure. And that's not a very effective way of sort of doing things. We have to come up with standards for things that can talk to one another. So today we have different interfaces for all the machines and devices across the network, proprietary APIs and payloads. I often will get into an IoT situation where I have no idea, once we turn it all along, how much bandwidth is going to happen. And it's going to happen to all of us if it hasn't happened to you already. And there needs to be standard ways of dealing with that. So the notion of true IoT has just not been fulfilled today. And we've got huge amounts of data. This is big data, and you may not need that big data. How many people here have basements? What's in your basement, sir?
Nothing.
Exactly. So you either have nothing or a bunch of stuff, and you've got a bunch of stuff your spouse or significant other is going on about you cleaning it up. And that's often what big data is. So we have to bring relevancy to that big data. If you're in the hardware manufacturing business, it's a great story. But if you're trying to move data very quickly, we want to put the right data in our data stores and move it through there quickly and decide by business demand what we want to keep. So let's look at some hard words here. So we're going to look at taxonomy and ontology to start with. So I've got the definition so you can get to it. And there's probably a couple of you that had 10th graders at some time in your life. You remember when you'll remember when we remembered what the King Philip that came over for good soup was. Anyone remember that one? For understanding phylum, chordata, all that stuff. Good for you. So the idea is that you'll see a little model there to the right of how humans are organized and animals and insects are organized in a taxonomy. This starts from the very general, those with backbones, down to those that may have gobs of glue, but there's a taxonomy for understanding how life exists, from the very broad to the very general. And data does the same thing. Metadata, of course, is data about the data, and we often think of metadata as information about an asset, about its CI, and so there's a taxonomy there that exists across an infrastructure. So the goal is to understand how much metadata you need to talk about a thing. You have a lot or a little. You want to have just the right amount, because if you put everything on there, it's big data, and now you're going to have to push it across the wire, and you have limited bandwidth. So if you have a city, who wants to dig up the street and put more wire down there because you didn't understand what 1 million or 10,000 or 100,000 IoT devices are going to do with their data models? So we see them as a proprietary today. I've got Spotify, iTunes, Google, and I can't move the devices from one to the other, can I? And it's it's lost. So taxonomies are the verticals. Ontologies are the things at the bottom of those verticals. And in a second, we're going to go on to the Industrial Internet Consortium, and you'll see what those ontologies look like and how you can use them in your own work. So ontologies. So there's some definitions that you can look at on the web, but essentially the ontologies are the DNA that's the bottom of the taxonomy. So if you're a human and you go down the stack, or an insect or spiders, you go down that stack of taxonomy, ultimately you get at the bottom, and there's your ontology that has your DNA. And the whole Human Genome Project was prefaced on this notion of understanding the verticals, the taxonomy, and then linking it to individual DNAs. Some of the words that we use in the ontology business, and we say ontology in the world of IoT, that's the data model. And so data models should be talking to data models. And the semantic web was envisioned that would happen by now. The folks that made the WC3 thought that by 1999 and 2000 we'd be using it. But the web today looks like a library. You go and you look for things and search for things. And ultimately, Wiki is a semantic web, but ultimately all of the web should look like that. So there's standards for that WC3 keeps, and that's one way to understand the data models associated with your things. And after the semantic model, you have the syntactic model, and that's where the machines are tied into some of those vocabularies, so it's machine-human interface that builds the web. So ontology is the DNA that lives at the bottom of taxonomies. The Industrial Internet Consortium, you can find that at iiconsortium.org. There's a model there to look at, a framework, and you'll see the link at the top, and you'll see what it's based on in the body of this argument. But essentially, it's a general model for understanding these verticals. It's about 14 columns wide, and you'll see aerospace, entertainment, oil and gas, and some of this makes common sense. And what they've done is they've provided test cases in each of those verticals to help you understand how your taxonomy works within that vertical and how other people's things, IoT devices, do that as well. And so today they're very general at what they prescribe, but anyone can use those test cases. So the link is there to have a look at. So we're going to play a little game here. And essentially, I'm going to give each of you a device. And some of you will recognize that really cool Arduino controller there. And so I'm going to give each of those devices, and you'll see I'm pretty cheap because that kit there is probably worth about $20 or $30. And I'm going to give each of you 10,000 bucks. And what I'd like you to do is take these kits home. On Hacker, we'll do a Hacker Day with IoT Charlotte. And to come back with a weather station that gives me your location, that gives me the temperature and relative humidity, and sends it to me. So you're going to go off and do that. I'm going to give you the 10,000 bucks because I'm a nice guy. So next weekend, you'll bring me back those devices. So I have one question for the audience. How many data models did I get back? How many APIs did I get back? There's about 70 of you in the room.
About 70.
Ooh, how many did I want?
One.
Do you see that problem? Give me back that money. So the problem is that none of you really want to share that. So today, we want to keep that private because that's how we make money. Because right now on IoT, on the hardware, we're making 30% margin. So no one really wants to change it. But we need to change it for all the previous reasons I've described. Because you have clients, and I just was the gentleman that took me through Snap AV, we walked through, and he said he had some 3,000 SKUs. I said, how many data models? He said, one. That's brilliant. We have a client that's the back end of Cisco that has 1,000 different products that are all smart and call home. Each one of them has a different ontology. So they opened up the valve this past May and sent it on to Cisco, and Cisco says, what is that? Well, that's 1,000 different models and all the data dumped into a pipe, and you open a socket and you can have it. Well, we'll spend the next year figuring out what that is. And we chuckled because it'd be longer than that. So they said, well, what if we just join all that stuff together? What happens when you just join all those 1,000 different products together? You get nonsense. Everyone gets this, right? It's nonsensical because English is overloaded. You have 50 ways of describing velocity, 50 ways of giving me temperature, 50 ways of describing location or address. It needs standards. And that's the big problem that we're going to be faced with. It's the one that all of us, each and every one of us in this room, is going to be faced with the next decade, and we've got to fix it now. And this involves getting to standards. That's the problem with interoperability.
Question?
Yes, sir.
So you made an analogy to language there, and human beings have no problem evolving the language, and humans on the planet have evolved from different language to different language.
Yes, sir. That's true.
And it's adapted. And
Yes.
so has computer models.
Yes.
And you're saying, you're painting that as a problem,
Mhm.
but you haven't really showed that it is
Sure.
a problem.
The problem is when humans are involved in it, it works. I was spent some time in India this summer, and I'm going to mess this up for a global audience probably, but I think there's something like 300,000 gods call Vishnu. Does someone tell me that that's even close to being true? That's a very
kind of story about the 5,000 names of God.
Yes, and the interesting thing about that is that no one confuses this story because everyone knows who's Vishnu they're talking about. And I've talked to many Indian people, they laugh at me, well, what's the problem with that? This is why we're good at math or something, I don't know. But I mean, that's a beautiful story because humans can get that. But when we're building machines and we want machines to talk to one another, the idea is that we have to be able to figure out how to teach the machines to do that, which will happen in time. That's part of the Google model, is dealing with the semantic that way. I'm suggesting that we can save on horsepower and electricity by building standards that talk to one another so that we don't have to go through that exercise. Because it takes someone some years in order to understand or appreciate how to deal with the interoperability that you just described, sir. Yes, sir.
I love the idea of interoperability. I work at a location where we deal a lot with transmitting information back and forth to different vendors.
Yes, sir.
And so obviously we've got our standards, right? But every once in a while, there's somebody who wants to do something differently.
Mm-hmm.
And depending on how much money they're willing to spend with us over the next year, we may roll out a specialized interface or specialized
Sure.
whatever for that.
Mm-hmm.
From a business standpoint, I mean, from a technical standpoint, I love the idea of a standardized interface.
Mm-hmm.
From a business standpoint, though, oftentimes it's just not an option.
Mm-hmm.
And how, I mean, is that something that we're always just going to struggle with? Or is that something that you see us trying to get the business to bring them back into that?
Sure. We can continue to struggle with, but we recognize that, let's just pick on smart cities, that struggle is a cost because you're worth dollars every day. And the idea is that when you struggle for it, that it has to be paid for, we need to pass that cost on to someone. So the notion is that how can I get the cost down? And if I have to express it as larger bandwidth to create more APIs, more interface, then that bandwidth has to be paid for by someone. If you just pick on a smart camera, for instance, most of those cameras create something in the order of 5 to 80 gig a day of data. Well, if I want that high resolution because I want the plethora of capability that high-end camera will do, then I pay for it in bandwidth, which someone will pay for. These days, it's globally somewhere between $5 and $35 a month per gigabyte. So you're paying for that lack of interoperability, often by transmitting more than you need to send rather than less. Yes, sir.
Well, but, I mean, in terms of bandwidth, you're talking about that being a cost. There's been lots of standards that evolved early in time, the telecom standards, the ISO standards, PKI standards, that use something called ASM1.
Yes.
And they did bit packing to compress the data down that they had to, in order to send complex things like cryptography and IANA type references and devices and
Sure.
stuff over a small amount of data.
Sure.
But that cost a lot of money
It
to
did.
both implement that standard and then disseminate the programmability of that.
Yes.
Nobody would use that today.
No, they wouldn't. And but one is not commoditized; it'd be specialized. But TCP came in that, or shortly thereafter, and the idea is that it offered us something with 10 base T and the twisted pair that we just didn't have before, and dealt with some other issues at the wire layer, at the physical layer, and so we left that. But ultimately, you're seeing the telecom stack. People are asking us weekly now, help us with serverless architectures. They're already gone through containers and it's already too much bandwidth. They want to get less than that. They want to send Amazon just their code and let Amazon own the server. And this is getting to that bandwidth issue, because if you're dealing with a city and you've got n amount of bandwidth, what you don't want to do is dig up the streets again because you've added the nth thing and now it's sort of broke the camel's back. It's incremental, but it's a very real thing. I'll take you through an instance at the very end of this deck that will tell you a story about a city that had this problem. And recently, you probably saw on CNN or one of the news feeds that there was a police department that lost its automobiles in Ohio because what happened was that they had all their cameras turned on and they didn't bother to pay their data bill. And the amount of terabytes that they'd earned under storage, because they came up with the rule they were going to keep the data for 10 years, do the math on 25 people, let's say 20 gig per day, 365 times a year for 10 years, and that's a bill at $5 to $35 per gig per month that got more than their cars were worth, and they lost their cars. Okay, I'm going to sort of skip over this, but essentially the open platform has a number of standards to help you with this. And you'll have these pictures, but OMI and ODF are what happened at the thing. And you'll be able to go to iot.eclipse.org where you'll see some cool examples, and you'll start to see at least 2 of them there that use these 2 standards. And just for your curiosity, most of it's written in Scala, and you can just use C shells or scripts to call them. So I mentioned a little bit about the ODEF, and I mentioned the UNSPC. UNSPC is the United Nations Standards Products and Services Code, which allows you to deal with interoperability of 2 different lists of things that are the same thing of different language. Essentially, it's almost like DNS. Say you call a cut rose rosa, and I call it red flower. The idea is that maybe that's ID number 7 that lives in a store someplace. All we have to do is address it as 7, and you can read it in Spanish and I can read it in English. That's a simple explanation of it. The periodic chart is another one. It's universal. Anyone can use the periodic chart, and it's translated to any number of languages. So ODEF is one of the standards that helps you deal with the interoperability of things. So this notion of taxonomy and ontology, let's see how great it's doing according to the to Gardner and the hype cycle. So you'll see where it is. It's at the bottom of the trough of disillusionment. And frankly, none of us in this room, including me, have found any vendors that have demonstrated any sort of special expertise at dealing with the metrology and building applications and tools around that sort of work. You find lots of open source tools, but there's essentially been no distinguishment about dealing with that space. So it's expected to sit there for 5 to 7 years before it crawls out of that. That tells me that there's probably is not as much interest as I think there should be in this interoperability. Maybe your point's dead on. Maybe it will happen that we'll just tear up the streets and build more bandwidth. Or in the case of 5G, we'll just irradiate all of us and put 200 microvolts per cubic meter and cook our brains out. We'll feel like we're in microwaves if we keep this up.
Well, we're going to do 5G for sure, and it's going to have the bandwidth of a wired fiber, so it's coming.
It's coming. So a short story on smart cities. So hopefully this will, it's got some color in these slides that'll wake you up a little bit. So a few terms about smart cities. They've been around for about 100 years in my estimate, and I've been messing around with this concept of smart cities for about a decade. There's been some technical and social novelty associated with smart cities. So when London burned in 1666, he built an organized smart city in a radius, and Sir Christopher Wren, as you probably know, designed our Capitol building. And so made London, cleaned it up, and it's hard to find a building in London that wasn't built before 1666. Another cool one is Octagon City. It was a smart city that was envisioned in the United States in 1856. It was for vegetarians only. Every shape in it, every house, street, garden, and farm was the shape of an octagon. And there's bits of it left in Iowa. The thing about these smart cities that existed before the last 30 years ago was like buying into a country club or paying dues to your local pool or to community that you want to live in. And it was paid for by you. And everyone else doesn't get to pay for it. You pay for it, and you get things like you want it. So that said, this is the shape of the normal company we work for. Things are happening in the world, and we get a CEO. Maybe it's publicly held. The CEO gets money. We all do what the CEO does in terms of the capabilities that have been defined for the strategy, and then the things that we do. And so all of us workers down at the bottom of this triangle and the CEOs at the top, everyone sees that model. Now we flip it upside down. This is the smart city model, where all the citizens are defining what things they need in order to make the city inhabitable or interesting to them, because they pay for all the resources in the city by their taxes or by their payments. So if you live in a condo or a shared apartment complex, the idea is that a bunch of you will get together and decide what happens. If you don't, maybe you'll decide not to pay the rent, or maybe you'll move out. But we've already seen some failed cities that we'll talk about what happens there. The notion is that CapEx is OpEx and OpEx is CapEx. When you're dealing with smart cities, CapEx is the things that you do to keep the lights on. That's not the case when you're dealing with the companies that you work for. CapEx is the things that you use, capital expenses, what you do to buy these desks, buy things you depreciate, build this building. It's the exact opposite for the smart city. So if you think about getting into that space and how you're going to finance it, it's something to consider. So the smarter city is driven by data. I claim that what a smart city is one that uses data and has a life cycle around it, so that all the value of the city is returned to the citizen who sees it. There is transparency of all the data. So if I pay for a new park, I see the cost of the park, and I see all the costs associated with it and so on. If I have internet that's free to the city, I see the cost of it, I see the bandwidth I get, and I know where the bad spaces are and how much time it takes me to get on and so on. So having transparency in the life cycle of data to generate value to the individual citizen is what a smart city does. Recently, the last 3 years, I'm seeing smart cities connect. I'm seeing that happen in Andhra Pradesh, in southern India. I'm seeing it happen in Belgium. In fact, in 2 weeks' time, I'm working with the city of Brussels to meet the people in Antwerp, where there are multiple smart city projects, and they've never shared the learning of the ontologies and taxonomies for things that they've had. So all that data, they've not shared it with one another. What happens if we share that data? Can we learn about it? Well, we've all learned about correlation isn't causation, is it? If you don't go and look, you don't often know. Now, I use the story that just because it rains and you sold umbrellas, does that mean because there's a relationship between rain and umbrellas? No, I don't think that there is. But you have to go out and find that out. So these smart cities are starting to come together. Super cities will start to happen. You'll see the east coast of Africa, those cities starting from Somalia and down the coast will start to connect. You'll see Boston through Washington, Baltimore, down to Atlanta, those cities starting to connect. And we'll see small cities in the Midwest that start to do it as well. Yes, sir.
People in Belgium speak 4, 6, 8 languages, but you're basically quoting French and Flemish when you. I'm surprised that they haven't connected. You know, I know there's a nationality difference between.
Yes. What's interesting is that the language that we're speaking today, whether you and I like it or not, English, has become pretty international, pretty global. And I go everywhere. I spend time in Russia and South America and clients all over the place. And I still feel pretty bad that I don't speak anything other than English and some poor Spanish. But English has become universal. And I think that if you're less than 35, the end of the MTV generation became a polyglot generation. I think in this room, 1/3 of you speak at least 3 languages. How many people speak 3 languages or more in this room? 1/3 of you.
Are you talking about natural languages or programming languages?
And then, okay, anyone over 55 that's programming at least 25 languages, raise your hand. That doesn't speak well for us. We're trying to sell standards, not the silliness of the software revolution that we helped to start. So data's an asset. It's sellable, tradable, reusable, maintainable, and it can grow longer or wider. In the next section we're going to look at is there's general purpose databases that are not especially long nor especially wide. And we all know who those brands are. Some of them are downloadable, MySQL, some of them you pay exorbitant amounts of money. And then there's wide stores that are great for certain applications, and there's narrow stores. It turns out that narrow stores are ideally fit for the things we do with IoT, especially when we're talking about configuration items of assets, and then the properties and the metrics that they create. If you create an IO instance of a thing, you probably have 4 or 5 fields that to sort of describe its existence, from its ID, its location, its owner, its brand, and so on. And then you have 3 to 5 things that it probably says probably does. So it doesn't have to be especially wide. But if you have all the IoT in an enterprise, it's nothing to have a billion or even a trillion rows. And to be able to have minimum latency for that is a column store. So a column store, wide store, general purpose database. So let's look at a couple of other things about smart cities. So I'm on the board of a thing called a Biotope. It's Brussels, Lyon, and Helsinki. And we're trying to deal with the disparity of IoT between those cities by using standards. And you'll see in this list here, there's Smart Cities Mission, which is India doing much the same thing. There's the Open City Platform that's happening in Oregon, where they're looking at geography as a mechanism for supporting various ontologies of things. There's San Jose with their Intel platform. And you'll increasingly see that vendors jump on the IoT bandwagon. And what happens when you build a smart city and it's led by technology as opposed to what the citizens want? Can someone tell me? Yes, sir.
People leave.
They do. They, in fact, leave, or it's like an IT project. Has anyone seen at least 50 IT projects fail in their career? We all have seen that. And so citizens will leave if we don't get it right. So essentially, bottom-up growth seems to be meaningful. Small cities seem to be doing much the right things. We'll talk a little bit about that. And if you go to smartcitycouncils.org and go into the resources tab, there's a couple of really cool planning guides, resource planning guides to help you with, if you're an IoT person and you're going in to talk about your IoT thing in a city, that'll help you with a checklist to sell to a public group what your IoT can do. Yes, sir?
Does it take a pre-built infrastructure to accomplish this?
No. The idea is that you'll see some smart cities, especially in Northern Europe, and even Bill Gates in 40 to 50 miles west of Phoenix, that they're trying to just do it from scratch. And then you'll see places like Auckland or Seattle or San Francisco that attempt to build with existing infrastructure. And there are some techniques for that to do it well. Because if you're going to take on a city, as an enterprise architect, one of the things I've done is tried to boil the ocean. Does anyone know that concept? It's a very bad one. I hope you don't know it, and I've done it a lot, which is try to fix everything in one fell swoop. It doesn't work. What you need to do is if you come across an accident and someone's laying there, try to find out what's keeping them alive and what's keeping them from dying, and figure out the minimum you can do and then work from there. If you just try to figure out how to make them comfortable, they've probably died. And often what happens when we go in these smart cities, we try to do everything. So the deal is to find out what the citizens want and to deal with that small list of things. And you may find it's dealing with homeless first. That's what I found on the West Coast. Dealing with the homeless management information systems, the HMISs. You fix that and lots of people are happy because lots of people are now no longer in the streets, and it deals with some branding of the city. And then you go after some healthcare stuff. So there are some patterns about that, and there's some great books and texts that are out there. And if you get particularly interested in it, there's a sociology about it that, to keep my job, I've become more familiar with, and I can help you out with some of the learning that you might think about. That's a great question. The idea is that you can start from nothing or start with something. 1932, Frank Lloyd Wright had this concept of the broad acre city. It was never built, but all the products that were in the city were designed to be made in the U.S., and the water system was going to be owned by no one. It was an interesting concept that was never built. Everyone had 100 acres. Everything came from the city. It's failed. We've had a number of these attempts to build these kinds of cool things. Seward, Alaska, 1967, the Alaska pipeline was finished. There was a notion of building a smart city there. It was all enclosed to keep people out of the weather. Tandy Corporation, remember them? They made mainframes. Tandy Corporation owned the land, wasn't able to keep up with the payments, and they lost this instance of a smart city. So this was never built. Smart cities do fail. Let's look at some that seem to be making it. So this is our biotope. So Brussels, Lyon, and Helsinki. We went, polled the public, and found areas. So each one of these little areas on this chart, and you can find this at biotope-h2020.eu, is a use case that people in the city have signed off for. They believe in it, they want to support it. We're going after solving it and dealing with interoperability. So when school children are getting out of school, the crosswalks work appropriate for them. The traffic cameras work appropriate for them, yet those were different projects. So the correlation of use cases came together in this story. You'll also note that, at least in Helsinki, there are some smart buses, autonomous buses, and I've worked on a couple aspects of that, and the ODEF is useful there for dealing with the interoperability of systems that make buses autonomous. So smart grid. It's interesting that the electricity that's powering this room was made how long ago? Does anyone want to guess?
120 years?
5 to 7, well, good one, that's actually true, but 5 to 7 seconds ago, this electricity was generated. It's not a very efficient model because in this model, the power company doesn't know what's there. They have to make extra, and then run the variance to ground. The idea is that we can connect people's homes back to the grid, back to panels, back to coal generation state, and we can be more efficient. Up until a few months ago, a gentleman that had a smart home in Helsinki used to let me operate it in the talk. So I would show you how I could change temperature in his house, how many people were in the bedrooms, that are sleeping or not, because he had CO2 devices in there to see how much carbon dioxide was in the air and so on. But someone played with my laptop in a conference that we had and turned on all their lights and flicked everything on and off because I wasn't paying attention. And so he's taken me off that. But the notion is to be able to have your home that smart is fascinating. What they've learned to minimize colds, influenza, in Helsinki is to have a slight positive pressure of 1.5 bars in each smart house because it puts a solid pressure in the house compared to the outside. And what we've learned is it makes people healthier. We only learned that because of having all the metrology associated with a smart home. So the Open Group has as its motto, or one of its mission statements, is enabling boundaryless information flow. That actually came from a former CEO of GE who came up with that concept. But that's the kind of the notion that we live by, is how can we have frictionless flow from thing to thing rather than having to deal with all of our infrastructure and piping it around. Again, the red lines deal with our OMI and ODF. An open platform is the mechanism for having a singular platform that service catalogs can talk to and things can be underneath it in their verticals. And I'll show you a nice picture coming up. Some failed in New Smart City Initiative. So Songdo in Republic of Korea and South Korea. 2015 it got started. Bit of a problem there. Someone answered this one already. Cisco led that, and there's some of the stories about it that you can see from the link. But essentially what happened is that the cost overrun of the IT drove the average worker out who was doing things like working in retail. They couldn't afford the cost of the facility. So the technology drove them out. So the goal is to figure out what the city members, citizens want, rather than having the technology company drive in. I got to spend some time with the CEO of CB Richard Ellis last month. And he told me about his great plans for building these smart cities that they had all the technology vendors signed up for. And I said, well, who are these citizens? Well, we're going to recruit them. We're going to want to move here. Do you think the average Joe is going to want to, sorry for that notion of the average Joe, is the average person going to want to work there who's making just over minimum wage? And what about, in terms of future state, modeling that when you recognize that 2 billion people on the planet don't yet have a savings account? That today, 13% of the world lives on less than $2 a day. The sharing model is not looking increasingly great for building smart cities and people moving in if it's not based on the demand of the citizens rather than demand of technology. So the Bill Gates address is there. Auckland's there. If you go to Twitter and subscribe to Auckland Transport, you'll see great little applications that they're doing in terms of how they're growing their smart city in an existing city in order to deal with projects that the citizens want. And the Nordics are doing the same way. They're trying to recruit you guys by having cool conferences where the holders of the conference are actually city planners. And so they're looking for things that you do and try to figure out how to sell to citizens within the city. One slide that essentially says the bottom point, which is when we don't have interoperability, 80% of your time is spent by a data engineer trying to resolve all the different kinds of data that exist within the IoT or big data space that's been defined. That's a lot of time. Then your data scientist gets a hold of it, and then we can see value. If we deal with the interoperability piece, we can remove that 80% prep time and make it something simpler. So some reference models. This is not original work, but yet it is. So I've been trying to come up with easy ways to talk about sort of the 4 use cases associated with machine to something, machine to star. So here's the 4 pictures that I've come up with. Essentially, it's machine to analytic, machine to machine, machine to data lake, and machine to process. I don't include web logs or where people will, I claim IoT wash, and use server as a machine. These are the things that you and I know, Arduinos, essentially small footprint things that are proc fabric and storage. Processor with networking with some level of storage. I don't generally include those. The first one, machine analytics, the easiest one. I have a son who lives in New York City. Every year we've given him a smart thing. He said don't do it anymore because he has 5 brands of door lock. How many interfaces does he have, sir?
5.
How many does he want? 1. Exactly. So all of us have bought that smart stuff, and now we're throwing it out because we want one interface. So we've seen that. It's easy to get metrics on that stuff though, because it's a machine to an analytic. The idea is that on the race car example, an engine temperature light, the status, and having it correlated to a data store, column store. Oil and gas, having IoT on the well rig. There's about 30,000 sensors in the average well head in Norway today. And the idea is doing the machine analytics piece is easy. It's those rest of those things that are a little bit difficult. So in these next 4 slides, essentially I'll show you a small, medium, and large data model. And obviously the small in this case doesn't require a significant amount of data. My old VW bus would almost do that because I did have Arduino in the dashboard. So I was doing a little bit of storage. The medium model, this is where you get some smarter houses and so on. And ultimately we start to predict data. This is where you get into your larger models. And I claim that when you're looking for your iPhone, that application is in existence as an example of M to A. Machine to machine, this is what most people are talking about. So in the morning, what happens at my house is the alarm clock goes off, turns on the coffee pot, also turns on the toaster, and they're different brands. So I have to use smart plugs. If they're all the same brand, maybe they would connect to one another, but they don't today. And essentially, if any one of them breaks, it's okay. I can see it when I come in, but ultimately, as a result, there's a bunch of processes and I get some result that I can see. And that's machine to machine. And in the familiar case at home, we can see how that works. We've been doing it for decades. It's not particularly smart. When you get in some of the newer homes or people like nerds like us, I suppose, what we'll see is that there's branded versus open standards with things that are happening in our household. And increasing, we're getting more data. We're starting to build data stores in our house or in the cloud in order to store this data. And ultimately, you've got where I live in Seattle, I actually live on a boat. And the guy that lives on my dock is, who's the former CEO of Oracle? Thank you. His camera guy lives on my dock. And all of his boats, he's got a fleet of boats apparently, all of his boats have column stores, actually it's Oracle, have data stores that are not column stores, to hold all the data that all the cameras all of his yachts do. So apparently he can look inside the refrigerator and see if someone has taken his moose meat. Pretty funny stories of what happens in the Larry Ellison world. In the formal state, if you've grown up around Mr. Rogers' Neighborhood, you remember seeing those old black and white movies of the popcorn being made or Twinkies being made and so on. And that primitive kind of IoT was that the conveyor belt was working, that was jammed, the mechanical arm would stop and so on. So we're all used to that story. Those factories are good stories for us, and I think you're looking at some of those in the businesses around here. As you get into some of the newer machines, you can look at some of those older ones and decide if you're going to stick with the OEM devices or to retrofit them with servers, counters, and sensor logs. And so you start to add column stores and start to get more and more data. It's a risky case because there's people that hold those jobs and it appears expensive to them. But increasingly, every day that we live, it's getting cheaper and cheaper. And finally, digital OT, these smart factories. I go into some of these car factories where there's very few humans that work there. The Tesla plant has about 500 people who work in it. Normally that would have around 3,500 people. And in those locations, you'll see incredible amounts of data that's being shipped in order to do work. Machine to data lake, I see this one incredible lot. And essentially what happens is lots of IoT going to lots of data stores, going to data lakes. And this is where we see a lot of instances of Vertica. We're doing a lot of prep time and ultimately going to a reporting DB and ultimately to the business questions that are being asked of that data and on to business value. So in the familiar case, we all know this story. You've got an Echo or a Siri. They're not interoperable. And maybe in time those will. But that's the frustration we're seeing with that interoperability. In the formal case, the idea is that organizations, many large organizations believe they need to save everything, and that's costing them. And the idea is to help them see that not everything is interesting because we're tracing business value in our strategy down the stack to this data. So CEOs will say to me all the time, if I buy your solution, how many days until I get value? That's a great question because what I know is it takes 14 to 18 months to build a data science team. And what I know is we spend 80% of the time trying to massage that data, to clean it up, to give it to the data scientists to rend business value out of it. So those are some stories that you can use to think about that. And lastly, this is the place we all want to be. I think there's tons of value in look at this, and I really love sort of thinking about what happens here. But essentially, you've got IoT going to events that have happened across the infrastructure, and tools like SAP, Enterprise Asset Managers by Oracle, some business process managements know how to deal with those event handlers when some exceptions happen, and they'll send a message on to the vendor or the manufacturer to do something, and they'll either fix the IoT by fixing some firmware and sending it back down to the IoT instance that gets installed, change the supply chain, getting another part, or actually sending a message to a human system machine in order to change this part. Again, there's a familiar and a formal case to it. The formal case is interesting because sometimes I have trouble just getting the staff that's working at the control layer around these things to want to see change, to want to correlate events, because they're used to it being done by SCADA, where it's proprietary things. And now we're opening up so that all the events are correlated to a singular data store. I'm going to skip these notes. You can read these together. But essentially, those 4 models can be interoperated with one another. You can mix them up. Let's look at some common plays. The 2 big ones are event correlation and then predictive maintenance. So event correlation is interesting. Imagine that you use a column store, a data store, to take and act as your syslog. So you have thousands of devices, and when you're configuring it, syslog, you point to this particular address. That's the first piece. As you do that, obviously, it's going to be a lot better if it's structured data rather than non-structured. In the structured sense, you're now trying to correlate to a column, and now the time to value is faster in order to get that to the business people so they can trace it back to some strategies trying to be solved. So the event correlation using a column store in the enterprise, I think, is a great story. Places like Boeing, where it has 100,000 ticket events, service management ticket events per month, and millions more events, this would help complex failures go a lot faster. If you imagine hundreds of machines, and all of them have dependencies on one another, and you're trying to drive all those events into a single column store, and now what happens, we use what's called a 10-second, 10-meter rule. If you organize things by 10 seconds or 10 meter, and you can pick any increment you want, you're likely to find where the failure is. If that camera stops within 10 meters of it, it's probably, Don kicked out the plug, maybe the power went out. All of that's within 10 seconds or 10 meters. There's some goofy little rules like that that I use within infrastructure to help solve problems by driving all the events to a singular column store. I've included a few drawings here, but essentially any of these functional boxes can use a singular column store to dump all of their syslogs into in order to generate value or look for root cause. This is a particular story that happened in Seattle. Not a great picture, but it's a coffee company. If you've been to Seattle, if you've been outside this building within 2 miles, you probably know the coffee company I'm talking about. What happened on a particular hot day is somebody climbed up on the roof and took a baseball bat to some air handlers. It was a hot day in July. When they did that, of course, all the coolant dumped out on the rooftop, and the alarm system came up, and the police cleared the people off the top of the roof. Okay, it got hot in the store. The air conditioning guy was called. The store manager opened the door. So as they opened the door, what happened to any of the air conditioning that was left? It froze up. The closets that had all the switch gateway for this particular coffee shop, all the plug molding got hot. As it got hot, it turned off all those network switches. When that happened, all the POS managers happened. So that particular coffee cup company has a rule that if you can't pay for it with your card or smart device, you have to pay for coffee. So they gave away coffee for a day because they thought it was a network problem. But all these things were correlated together. And so what we ended up doing is using one column store to dump all the events for the DCIM, the Data Center Infrastructure Management, the SIEM, the Security Information Event Management System, the logs for the switch stack, and then the POS logs, all that into a single column store. And we correlated that by time and distance, and now we could see that that event that happened on the rooftop was in fact related to the event that happened with the overheating of the switch content. Just a couple of quick things. We're all interested in machines, and I've mentioned machine and showed machine pictures a couple times, but the idea is that healthcare is another area for IoT to jump into. Some of the cool things I've seen with STEM and some of the Girls That Code programs have been after making really cool devices with Legos and Arduinos and so on. Healthcare is a great way to go after. Aubrey de Grey is an interesting character to read about because he's trying to figure out how we can build actually data models that look at the maintenance that you've done on your life over time to figure out how long you should live and what you can do to sort of make things better. There's some interesting conferences at that. I think that going to conferences and using Twitter to find the conferences is a good play. We're doing it within our organization. I'm the guy that gets drafted to go figure out what they're talking about, write a paper, get it juried, and see if we can get in there. And this one's coming up in Berlin, how to undo aging. Often we think that if you want to deal with predictive maintenance, you go to an airplane company like Boeing. That's not the right answer. Go to the machine company who's putting together the machines that go to Boeing. So we had some cool machines that we got to see a couple of months ago that keeps track of every rivet that's put in every aircraft that they ever built and keeps it for all time. It's not made at Boeing. It's that's exactly right, it's Bosch. And you'll find that some of those vendors live in Charlotte because they have pieces on it that go on these bigger pieces. This is this global market. So as you look for predictive maintenance, which is a great story to figure out if I've got a machine that has some life cycle associated, what is the health, performance, and capacity of that individual object, looking at those metrics, correlating that over time in order to predict how long this machine is going to last. This is a common picture that I work with our clients, and I do it over and over again. I'm going to show you 3 of them. They all look the same. Essentially, strategy at the top left, the things down at the bottom. This one's the factory. This is using data aggregation as a data historian. Does anyone work in the data historian space? There's about 200 vendors that play in that space, but essentially they're looking at all the IoT that lives in a factory, and then we ultimately correlate that to the far right where we have an instance of Vertica that we correlate to value. I'll show some that are more appropriate. This is a Russian cell phone company that wanted to be able to control the antennas on the cell phone in azimuth and elevation so they could find out you're using an AT&T phone and move that antenna to point to you and your phone in order to draft that traffic and take it away from someone else. So in order to do that, they had this massive fabric of IoT, and ultimately it was so much data that was burdening the network, so we used 2 instances of Vertica, one that's using a data aggregator to create write data, also called liquid data or light data, and then ship the data that's appropriate back over to the enterprise, where there's another instance of our column store, and then we turn it over to value. So essentially using the column store as a mechanism for managing the bandwidth. And this is a great story if you don't have great interoperability. Same picture, and you'll see a machine learning model there, both unsupervised and supervised, and that model's become classic in that space. If you're interested in these models, I keep hundreds of them, send me a note, tell me the number that's on the slide or describe it, and I'll give you the visuals of these, because I think these pictures are really reusable, this notion of having curated data to write data and fit-for-use data as you build your enterprise IoT. So a couple of terms here. I think I've covered most of these, but essentially latency, how long it takes for things to react, interoperability, we beat up. I'm going to cover interoperability just for a second because I got myself into a little trouble with our sales team with a car manufacturer in Michigan someplace. What happened was that they were showing these cool autonomous cars, and these cars were sort of going around holes that were in the pavement. And I said, well, I drive an old VW bus. Does that help me? Can I get them a smart card? No, you don't get that data. That's proprietary data. I says, you mean that data's not open? No, that data's not open. That's our data. And I was thinking about the Good Samaritan rule and things like that. Should data be open? This is a movement that's happening today to make data transparent for all of us. This is another reason for having data interoperability, is being able to have transparent data so that everyone can have access to data for the safety of humans. Now, interestingly enough, and I think I've covered those other words, when we get to Auckland Transport in a second, or the city of Auckland, they're actually believing that, so if we go back to when our Constitution was created, we said that we have life, liberty, and the pursuit of happiness. Well, the happiness was in the 3rd copy. The first 2 copies, when Jefferson was writing that, was about life, liberty, and the ownership of property. And that was removed in terms of happiness. Well, some other nations are thinking about it like this. If I'm in Auckland and if I'm in New Zealand, I'm a citizen, shouldn't I have the right of safe passage from my threshold when I leave in the morning, go out to whatever I do, my job, and come back again? And they're using safe cities, smart cities in a way to build up that guarantee that I should be safe in that transit. Interesting concept, some of the things that we're starting to see with data. An interesting metric from this past September with Gartner, they claimed about 0.5% of the data that's in data lakes is actually traceable to business value. A scary thing, and all of us are responsible for it. So what we want to do is to help define what data that goes in there. And in this particular audit, because it is IoT, in some fields I would talk to, big data is critical for looking at disease control and things like that. But in the IoT space, I think we want to rationalize that data. Thank you. So I'm going to, go ahead.
Is that because you have statistically normal data and nobody cares about the first 2 deviations, so you're only looking at 3rd deviation out, which on each end? Or is it because we're saying too much data, or is it, you know?
Well, you're right in all of that, because what will happen is out the thing that's killing us. And it may be in the first 10,000, it's not interesting. So if you ever look at those Gartner reports, if it doesn't say 1,000 on there, I typically don't even read it because it's not enough large population. So the calculation is big N versus little n. Little n is typically a small population. I look for big N's. And so there are applications where it's absolutely least cost routing is one of them. But some of the stuff we're doing in IoT, we can be statistically viable with a smaller set of data. So I'm going to jump to this picture right quick. And essentially, this is summarizing what I described earlier with little Verticas doing aggregation and then sending on the summarized data back to our big data repository that's correlating lots of instances of data. So I may have many streams that I'm correlating at V sub E compared to V sub A, where I've got a bunch of IoT here. Does that make sense? Go ahead, sir.
Are you reducing at those leftmost, or are you storing and the ability to query comes back down for metadata collected at the higher level? Or?
Sure. The idea is that I don't need to keep all the data. So at the control plane, operators will think that they need to keep all the data. So ultimately, they'll come up with the business questions that need to be asked of the equipment they have and only collect the data that they need. If you read the stories about Rolls-Royce engines, for instance, they generate something like 800 gig every hour. But they don't need all that data, nor do they process all that data. So the goal is to find out what business questions we can ask of it, provide that to our data scientists, so that they can look for some interesting new trends that we never thought we had questions for, and get value with that. But that kind of serendipitous discovery is rare. It happens, and we can plan it happening, but it doesn't happen enough to sustain our IoT feed, need, and desire to sell more of it so we can monetize it to get the cost down. Does that make sense? So the idea in that picture that I showed is that to preserve bandwidth, if I don't send all the big data across my thin network, I don't burden it.
Good understanding, but are you actually doing pre-aggregation there?
I'm cutting
it
it down.
Storing it in a distributed model so
No.
that the query can come back down?
No, we're not. We're not going to keep it. DevNull is our best friend in this regard.
Well,
Whoever thought DevNull would be your friend? So the two big stories here, and I mostly have covered it. I'll look at it in more depth here, but I'm going to kind of skip through this. Predictive maintenance and enterprise event correlation. And essentially what Vertica is a column store that's purpose-built just for this kind of work. It's not a general purpose RDMS. It has R built into it. How many people have worked with R? Good for you. I forced my children out of Excel, because I've never bought a Microsoft product in my life, and to use R. And the three that are engineers like me and the two that are lawyers don't. So R is built into this product, which enables you to minimize latency there simply because you don't have the overhead of sending it to another product. It's SQL. It has an ANSI, essentially the advanced version of ANSI 93 that we all grew up with. So that's a great story in terms of that. Finally, three quick cases. Vertica has built-in integrated machine learning. The thing that I use 90% of the time with it is probably going to be regression. This is the idea of forecasting with confidence intervals, what's going to happen today, tomorrow, and the next day based on the previous week's worth of data. That's just a common thing that you'll see. And the idea is how long should a thing happen, when's it going to happen next, trending. The next one is being able to get data in there quickly. We use open source products. So Apache Kafka is one of them. And so if you're trying to load something over 10 million messages per minute, this is a good story to get to. So the fact that we're using open source in this case is a good story for us. And ultimately in the IoT space, in order to deal with mapping, the idea of having geospatial built into it, the ability to do pattern matching with security information event management systems, I mentioned earlier, the SIEMs, and to be able to do aggregate projection like personal billing that you might see in a power system or community using solar is built into it. So finally, these are all the built-in machine learning capabilities that are built into the tool. Again, you'll have this deck, a couple of them that will make more sense to you as you see them graphically to help you remind what they do. And I showed this picture earlier as well as this one. So lastly, talk about 1 minute about Auckland Transport. This is a city obviously that exists. So how can we use value to keep people happier in a city? Slovenia has 540 railroad crossings. I know some of them intimately. In the summertime, 1.5 persons die per month getting run over by a train. In 2017, that seems silly. So why should we make them smarter? And it turns out if you're driving a car and you see a red light, you stop. But if you're driving a bicycle or walking and the arms go down, what do?
Walk around.
You walk around them. And people do, and they get killed every year. And so the idea was be able to use cameras with IoT in order to make the city safer. If you've been to Auckland, and how many people have been to New Zealand? One, two. The cool thing about Auckland is that they had some interesting ideas. And one of them is that they can use cameras and smart signaling to understand where people and cars are across the broader city, to understand journey times. So we keep track of all that. So we have cameras and we're understanding journey times, the velocity of cars and what cars are doing, the difference between a cab, a bus, or a motorcycle, a bicycle, or a person. And we actually read the license plates to understand that. We don't use them for doing tickets because of some GDPR stuff, so we're smart on that. But the cool thing is you probably know in Auckland, you can cross left or right or diagonally. So we can shut down the whole intersection because there might be 4 to 6 people at a corner, and we actually count the people using cameras. And once we determine there's 4 to 6 people, it has priority over 2 or 3 cars that are coming down the street. So it's making the city more livable. So this is a pattern about how we used Near-Realtime IoT aggregation in order to support their Safe Cities initiative. There's articles all over the web with that. We started out with 700 cameras, then went to 1,700, 2,000, 4,000 2 months ago, and now we're getting ready to go to 8,000 cameras. And so we have 8,000 cameras plus all the health, performance, and capacity of every individual IoT instantiation used in the city infrastructure. So we had lots of discussions about standards there, and I will tell you that very little of it actually sunk in other than the platform. And I'll show you that in one slide. But essentially, they heard it. They are now participating, now speaking at the open group. But these are some of the standards that we presented to them to how to correlate value. And someone mentioned earlier about cameras. In their case, they had about 32 camera models or brand manufacturers. Each one of them had 4 to 6 models. Each of them had their own ontologies. And when I got there, 65 to 75% of the bandwidth is being consumed by camera traffic. Who thinks that's a good idea in a network? No one does. What number would you like to see? 10 to 15% is a number that I like when I have some activity like that. So to get it down, what did I have to do? Well, those cool proprietary standards, what do? Lots of cool stuff, bells and whistles. We had to cut down on that because we didn't have the business cases to support that capability. So when we went down to something dumb like H.264, now the bandwidth was down to quite a bit lower. And so cameras were doing 10 to 20 gig per day instead of 70 and 75 gig. And now we're down in that range of 10 to 15%. So those are the kinds of things that will happen as you build your smart cities. This is a platform, and what they had there was not what we have here. I drew this, and essentially a platform across the top with verticals. You'll see Microsoft's E911 solution, a parking solution, a number of camera providers, the camera in this case being IoT, an aggregation engine. You'll see Vertica there. We're correlating all the verticals with all those events in order to talk to the ticket system. So if a camera's dead, we're polling cameras to see if they're alive or not. They didn't have that capability. We're using the column store in order to report that. Again, this picture, which you saw. My last slide. Thank you for staying awake. Blockchain. I've become quite passionate about blockchain, mostly because of my family. So I've raised 7 kids, and 3 of them have worked in Africa at one time or another. My sister works there now. And her boss won the Nobel Prize some years ago for microfinance. And so microfinance has been something I've had to hear about for the last 15 years. Well, that's not true, last 10 years, I suppose. And microfinance is this notion of loans that are somewhere between, say, $5 and $50. And nano loans are somewhere between $1 and $10. And when you imagine that there's 15, 14% of the world that lives on less than $2 a day, that's a lot of dollars, isn't it? It's a lot of money. And the problem when some of the less sustainable places like Africa, where there's 2 billion people who don't have bank accounts, is how can they get it without any infrastructure? When the drag on getting your loan approved means it has to go up to some data center to get approved and then back. Well, what if...
Cell phones.
Thank you. This is remote mobile qualifications. You've known me a total of an hour, 2 hours probably of my life. Those gentlemen out there know about me for, I don't know, you know something about me. There's 3 people in this room that know something about me. Would you let me borrow $5? Do you think I would pay it back?
Yeah.
Well, imagine how fast did that take? It took a second. So the idea is that if you were to go to a normal bank, that would take days to get that. They wouldn't do it. So it's about managing that cost of transaction. Imagine you apply that now to what you can do with blockchain, that we could have blockchain with IoT and now mobile and remote devices to deal with things like not just having loans like that, but what if I have a lawnmower and I don't? What if you had a lawnmower and I needed to cut some grass? You'd probably lend it to me because you've known me for an hour. And I seem like a reasonable person, but you probably wouldn't loan it to some guy that you didn't know, or to some big oil corporation maybe. But because we know each other, you'll do that. So blockchain is not just for Bitcoin. I think that there's a sort of a trifecta happening, and that trifecta has to do with column stores that are low latency, and think about all the least latent components of the enterprise. The column store, smaller messages because of interoperability, or fit-for-purpose data models. The notion of using the mobile to do payments in order to do it because of people that you know, because that's going to be more efficient than going up to a bank. And putting those together with light clouds that have open standards. If you put all that together, I think that there's the next generation of applications will be designed that include you with some of the topics that we just mentioned. Yes, sir?
Do you not see a problem right now with the blockchain technology where everybody is trying to apply it to everything?
Yes.
Okay, blockchain is non-repudiation,
That's correct.
distributed non-repudiation. And it's a really narrow focus to things that you need for a ledger, for example,
Yes.
for accounting.
Yes.
It is not a data store.
No.
It is not
No.
it's not lots of things that people are
That's
trying
right.
to apply blockchain.
And what's interesting is that this general way, lots of ideas will be thrown down the funnel, and a few of them will come out, and that's where we are now. I mean, it is a SHA-256. It's a lightweight hash. It's only 32 bytes. I mean, it's a lot of things, and we can decide what the metadata is. One of my earlier comments was deciding that the big companies have already decided in Facebook and Amazon and Google what the metadata is about a thing, about an object. And the idea is that in the blockchain, ultimately, we'll decide what we put in there. Will I put my whole life in there from the time I put my footprint on a piece of ink and was stamped in 1957 in Niceville, Florida, my whole life after that, all my degrees or whatever, or maybe the fact that I have a lawnmower and you don't, and you know where I live. I mean, I came over here on Uber, and as I was coming over here, I was thinking about what could I say smart here, because I've been sold, as you have, that that's part of the sharing economy. Is it really? I think it's a different kind of economy. The sharing economy would be this: I knew you had a car and I needed a ride, and he and I had some ledger that we were able to have an application that I knew it was available and I could use it and I returned it to you. That's a sharing economy. So it's a difference. So you're spot on that we haven't decided what it is. When Nashimoto decided what the blockchain was with Bitcoin some decade ago, it apparently has worked to the tune of, I don't know, what yesterday was $10,000 a coin. So whether it's real or not, I don't know. But, I mean, in fact, I'm going to say I don't know, but I am going to say that it's certainly a possibility of a thing. Go ahead.
Here's another statistic that I heard. Each ledger that is successfully produced, where it's a distributed computation that's going on, and
Yes.
there's one winner, okay?
Yes.
And when they win, they get a block. They
Get a block.
a Bitcoin mine.
Block.
And they've
Coin.
successfully transacted one block.
Yes.
That takes the energy requirements of an average household for a year to compute.
It's about 3 trillion cycles to solve one.
It's the average household energy. So, basically, these transactions in the internet that are going on with a little win scenario,
Yes.
they're not cheap at all.
Well, this is interesting because to be profitable at it, because if you had async boxes 5 years ago, you certainly would be making Bitcoins. In my neighborhood, people use the Bitcoin boxes to heat their boats. And they're satisfied today with $35 a month is what they make. But they're losing money on them, and you would be losing money for what we pay for power there. So people move to other places. They go to places where power is run to ground, because there's Nordic countries that have so much electricity they do. And they're certainly not using not GPU boxes. So it's fit for design, fit for purpose boxes that are used for this. So it's not just generalized computing that's doing that. So we've got a lot to go, but I think you and I would recognize that you and I, apparently, I think you were smarter than I am, but we didn't recognize what would happen with Mozilla in 1990, did we? We didn't realize that search was going to start e-commerce and turn the world upside down. And I think that recognizing what I didn't know then, I was working on Gopher at the time. Does anyone remember that?
Yeah.
So I was a Gopher. I compiled Gopher at National Science Foundation for the VAX. So I think that what we've learned is that this thing is probably important, but we don't know, we can't quantify it with a lot of dimensions. I just know that the average miner today has something on a Bitcoin, I think it's like 700 gigs. I've heard numbers between 300 and 1.2 terabytes for the size of the blockchain. And so that's starting to be a reasonable size for a column store in order to start talking about the minimized latency story. So I think it's going to happen in the next 2 years. And I know for a fact, and it's up on the slide, that DoD is using them to assure the supply chain for certain weapon components. That is to say that there's a hash that exists between all of us in the room that have made IoT and this particular machine that's here to assure that what I got in the package is what I think I got. So having those kinds of models are things that are likely we'll start at, but ultimately this trade story and the resourcing of a more effective capital model, I think are things that will happen in our future. So that said, that was 10 minutes over, wasn't it? 12 minutes over. That was a lot of materials, and I hope I've covered some of what you asked for. But thanks for your time, and thanks for the great questions. I mean, normally I don't get great interruptions. Your interruptions are always good, so I want to come back when I have better answers for you. So thanks very much for your time. It's a great evening. Thank you.
Thank you very much, Don. We
Sure.
really appreciate you, talking to us.
You bet. Pleasure.
Dedicating your time. And I look forward to talking to you after the meeting, too. Vertica gave us these really cool fidget spinners, but to earn them, you have to do the survey. So if you guys could do the survey, and
Do you want to sign us off?
yeah, you can sign up. So, thank you. That's the end.